Okay, now let's discuss about the wall thickness. So we will know how the wall thickness is caused for surface defects. So the wall thickness of the part being produced dictate the degree to which surface defect may be a problem. The operating parameter for thin wall casting are very different, right? The operating parameter for thin wall casting is very different that for parts with a thicker walls, and the die temperature, gate velocity, and the metal temperature are all much more sensitive for a thin wall parts, right? As you reduce your wall thickness, so the all parameter like your die temperature, gate velocity, and the metal temperature, you need to control all the parameter very close tolerance, in a very close tolerance. This is because the liquid metal is getting cooler as it is flow into the die cavity, right? It's a very simple logic to you can correlate how the wall thickness is related to the casting surface defect. When it is lose too much of its heat, surface defects are the results. So for aluminum and the magnesium casting, you can say the point minimum, minimum wall thickness is like a point zero 0.02, right? And the for zinc, point zero 0.06, sorry, point zero 0.06 inches is a typical minimum wall thickness, and the for zinc casting the minimum is about zero point zero 0.04 inches, and to consistently produce good casting with these thin wall thickness, how very good job for processing engineering is required. Okay, so this slide gives some example of the fill time reduction required when the casting wall thickness is reduced. This is a very simple logic. As you reduce your, casting thickness, so you have to reduce also your fill time. So when the wall thickness is reduced from 0.08 inches to 0.06 inches, the fill time maybe need to be reduced by 25%, right? So on the other hand, when the wall thickness is reduced from 0.14 inches to 0.12 inches, it may only take a 12% reduction in the fill time. All right. Okay. Some other tips for producing thin wall casting are shown in this slide. The gate should be feed directly into a thin wall section, right? This is a very important, parameter. So the gate should feed directly into thin wall section, especially when it is the critical quality parameter for the part. In fact, the ability to feed a thin wall section will usually dominate the consideration concerning the location of the part in the die. So this wall section will require a low fill time, right? Sometimes you will find the in the same casting there's some section have a low wall thickness, and the some section has a high wall thickness, like 5 thickness some section has, and another section have a 2 wall thickness. So you require a separate gate. You should directly feed that section with a minimum filling time, right? So we should dominate the process selection, and this thin wall section require gate velocity that are the high end of the normal range, and they may have exceed normal gate velocity for very thin walls. So when you are designing your gates for a casting, so you have also divided your volume of the casting so that give the gate velocity as per your casting section, which have a low wall thickness or high wall thickness. All right. Okay. Here are the main wall thickness issue for thin wall parts. Talk to the designer early so that the accommodation can be made for thin wall process requirements. Try to keep the wall thickness uniform throughout the part. keep the wall thickness variation to a minimum by insisting upon a smaller tolerance for the toolmaker. All right, and also the process window will be a process window which is related. We are talking about process window from the PQ square diagram. So the process window will be much smaller, requiring tighter process control. As I earlier told you, the process range like metal temperature, gate velocity, and die temperature, all the require the tighter process control. The fill time must be fairly fast to fill the low wall thickness casting. So try to use a gate that feed directly into the thin section. So minimize the flow distance through this area. High gate velocity will be needed, but they should still be within the normal range. And one more thing I would like to tell you, if you are increasing your gate velocity with the lower filling time, so you need also increase your machine tonnage. This is a very important thing. The most die casters will forget when they are designing low wall thickness casting. So as you reducing, right, as you reducing your wall thickness, you have to be increase your machine tonnage so that you all keep your casting without flashing. So finally the die temperature will need to be higher than the normal to minimize the heat loss during the die filling.